Good morning, students. Today we are going to see how are we going to configure the ASA 5505 firewall, allowing the end devices to access internet using NAT. So let me do the topology arrangement. We need to configure the router through the PC using the console port. So I'm bringing in a PC here, and then let us have a end devices. Let me have a switch and two more PCs for accessing internet, and let us have a router. And also we have a web server. Let us say that that's going to be the web server which need to be accessed by these PCs. So let me connect the PC first. And now let us connect the firewall. Let us actually assign the IP address for the machines. Let us configure the router. So we'll assign the shown IP address for the interfaces. So this will be 50.1.1.2. This will be 10.1.1.1 for this interface. So just we will do that. There will be default IP address assigned for the interfaces in the router, so that need to be cleared. So let us just see what is the IP addresses that are arranged by default. So if you see here, interface VLAN 1 is assigned with 192.168.1.1, and also DHCPD address is 192.168.1.5 to 192.168.1.36. So all these things need to be cleared. So let us do that. On terminal, interface VLAN 1. So there is an IP address for interface VLAN 1. So let us clear that also. No IP address. So this should clear the inside IP address. Also we have to clear the DHCPD default IP address range. So let us do that as well. Exit. no DHCPD address. As you see here, it is 192.168. So let me copy that one and I will put here address. The address inside, isn't it? So DHCPD address we set. So let us remove this. So no DHCPD address. So it is done. Now let us go and configure VLAN 1 and set new IP address there. So interface VLAN 1. Since we removed the default IP address, we have to assign. So that is going to be IP address 10.1.1.1, isn't it? So that is what we have shown in the configuration here, and the subnet mask 255.255, sorry, 255.0.0.0. No shutdown. So now name if inside we have to set the security level 100 for inside actually, and the inside security level is very high. We set as 100 in the ASA, then exit. Okay, now we have to configure the Ethernet interfaces. Interface Ethernet 0/1 and switch port. Actually, this command I think we are familiar with. Switch port access VLAN 1. Exit. Then we create interface VLAN 2, and this VLAN is the outside network. Okay, so we have to assign the IP address 50.1.1.2, right? So this is actually the interface that we are assigning for VLAN 2 space the subnet mask 55.0.0.0. No shutdown. So that is also up. Then name if outside. For the outside we have to set the security level 0. For the inside we set the security level 100. So now for the outside we are going to set it as 0. Exit. Then config interface now let us check the IP address of the VLAN 1 and VLAN 2 show running config. So you see here the VLAN 1 IP address is 10.1.1.255 subnet mask. That is actually this network. This interface is assigned for VLAN 1, and this interface Ethernet 0/1 is assigned for VLAN 2, whose IP address will be 50.1.1.2, right? So these are the two things so far we have done. Now let us configure the IP address in the router. In the router we have gigabit Ethernet 0, and that IP address will be 50.1.1.1, and let us on it. And the Ethernet 1 on the other side, 0/1 will be having the IP address 1.1.1.1, right? And let us also on it. Now let us configure the server IP address. The IP address will be 1.1.1.10 subnet mask, and the gateway will be 1.1.1, isn't it? Gateway will be 1.1.1.1. So we finish it for now. So the configuration is done, all the interfaces are up and running. Now let us configure the DHCP and DNS in ASA, right? So now what is that we want is that these machines, end machines, to connect to this web server actually. So we need to configure the DNS for this machine to identify the IP address of the web server, and then we will also, we have not assigned the IP address for these machines. Let us assign the IP address by DHCP from the firewall. This is what we are going to do as the third step. So let us do that. So let me configure the route ASA firewall for DHCP and DNS for the inside network. So we will terminal and let us do the DHCPD address. You have to give the range 10.1.1.1 is already given, so let me start with 2 10.1.1.30 and let's say inside. Then let us configure the DNS also. So it is actually DHCPD DNS. DNS is, our DNS will be 1.1.1.10, isn't it? 1.1.1.10. Interface inside. Okay, so now this is done. Now we will check the PCs whether they are able to get a DHCP IP, and then they are able to ping the web server. So now let us check whether the PCs have got their IP address and the DNS entry. Let's go to the PC to desktop. We made it static earlier, now we are saying DHCP. So it got the DHCP IP address 10.1.1.3, and then if you see here, the DNS server IP also has come automatically, isn't it? So now the machines are getting the DHCP and the DNS detail from the ASA firewall. So far we are successful. Now for these machines to communicate with the web server, we have to configure the default route in the ASA, right? That we will do now. So let us do the default routing in the firewall. Route outside, let's say 0.0.0.0 and 0.0.0.0, and the gateway will be this one, yeah, 50.1.1.1.1, 50.1.1.1. Okay, so we have enabled the default route in the firewall. So let us see whether machines are able to communicate with the web server. So let us check whether the devices are able to communicate with the firewall. Ten dot 1.1.1 is the interface of the inside firewall. That's the interface of the firewall serving the inside portion of the network. So they are able to communicate. Now let us do the second task of configuring this router. Actually, we call it as the external router. Actually, the router from we can call it actually as internet service provider router, as it is actually closer to the web server. So let us do that. Actually, we have to configure Ospf here. So let me do that for the router. So let us and let us do router Ospf 1. Actually, this is the process ID, and let's say the network is 50.1.1.0, and then followed by the wildcard 0.255. Then we call this as area 0. So we'll also have to configure the network of this area, that is 1.1.1.0 network. One dot 1.1.1.0, and we call that as area 0. So the configuration of Ospf routing protocol in the router side is done. Next, we have to create object network and enable NAT on the ASA. So let me do that. So object network, we can give any name. I will call it as SUN. Then we have to just assign the network, the inside network, as a subnet for this one. So let me give subnet 10.1.1.0, then followed by the subnet mask 255.0.0.0. So now we have to create the NAT inside, comma, outside, dynamic interface. So we have finished creating the NAT and object network on the ASA. So now let us actually continue to check whether machines are able to communicate with the web server, because the firewall is inside. Until we will configure the firewall to allow the ICMP packet, there will not be any packet that will go through this firewall to the web server, though other configurations are done. Let us just check that one. Ping hyphen, sorry, let us just say ping hyphen t 10.1.1.0. we are just checking the inside interface. Sorry, this is actually the network address. Ping 1.10.1.1.1, right? So this is actually this interface. So there is reply. Let us stop it. Now let us try to ping the web server. That is actually the IP address is 1.1.1.10, right? So now let us see what is happening. This is the web server, right? So now this machine, that is actually this PC1 cannot ping, right? PC1 cannot ping. So let us see what about PC. So now we can see that the PC1 is unable to communicate with the web server. Okay, that is actually 1.1.1.10. Now PC2, let us try the same thing. Ping, if we ping this 10.10.1.1.1, the interface of the ASA, actually there is a reply. But if we are going to ping this web server, that is the ultimate objective, isn't it? You have to go to the web server with the IP address that is not yours, right? That is the idea here. So if I am going to do the ping 1.1.1.10, let us have a continuous ping hyphen t hyphen t 1.1.1.10. Of course it will not reply. So but the moment we are going to configure, see, it is not replying, request timeout. This will be continuous. So now what we will do, we will configure this firewall for access controllers so that these pings will get a reply from the web server. Now let me go to the firewall and let me exit and configure terminal. Let's say access list. You can give any name, access list any name. Let us say outside network, outside network for internet. I will give ONFI. Any name you can give actually for this matter. Then extended permit. Okay, so we will now let us finish our ACL configuration in firewall. Permit, what you need to permit, you can say TCP, ICMP, whatever. Now I will say ICMP, the ICMP packets, any, right? So it's okay. Then I can also say TCP, what type of packets to be allowed. Now we can completely restrict actually with the type of packet that we wanted to allow here. However, I am just allowing ICMP and TCP. Then we have to create the access hyphen group. The name we gave was ONFI. So ONFI in interface outside. Now you see here, until now there is a request timeout. Now the moment we say this is allowed, so I will say yes here, and you will see that the reply here in the machines from the web server, they are getting it. Now here also the same thing, you see the PC2 is also getting the reply from the web server. So that way we have configured our ASA firewall to connect to the web server using NAT successfully. So just to see the whether the NATing is done at the firewall level, we can use the command show NAT. So it will say that auto NAT policies 1 inside to outside, source dynamic, sun is the name that we have given for our interface, and the translated hits are 465 and translated hits are 465. That means our NAT is working. We can also use one more command, show xlate. So this is showing us, see here, ICMP port address translation from actually 10.1.1.4. Actually this is probably our machine. See, 1.1.4 is PC1 and 1.1.3 is our PC2. So when you see here, so it says that the ICMP packet, see this is actually the ICMP packet from 10.1.1.4 goes with the new IP 50.1.1.2. actually it goes with the IP 50.1.1.2. that means the inside machine's IP address is hidden, and the new IP address the packet header will contain is 50.1.1.2, right? So this is actually the NATing. So we have successfully completed these experiments. Thank you very much. If there is any comment, feel free also to contact me personally. I will give my email ID here. Thank you very much.